what you're supposed to know, ladies and gentlemen, is that a portfolio is a combination of what here? A portfolio is a combination of assets. It is a combination of assets. Now, what is the major objective of forming a portfolio? The objective is to minimize business risk. Not to maximize returns, but to minimize business risk. Now, remember, ladies and gentlemen, from those old days, we were told here that we should never put all our eggs in one basket. Don't put all your eggs in one basket, because if you're a beautiful lady, you're taking these particular eggs here to the market. And then, of course, if you're putting all of them in one basket and then you stumble on a rock, what will happen is that all those eggs, they're at a risk of, in this case here, ladies and gentlemen, getting destroyed, all of them. Breaking up, all of them. But if you had spread your risk, you are hanging with your two bags, one basket on the left hand, the other basket on the right hand, then you will salvage a few of them. There's a possibility of one bag, of one basket here, ladies and gentlemen, getting out of this entire mess alive. So the objective here is that we should spread our assets into what here? We should spread our resources into many assets. Don't put all your eggs in one basket. Don't tell me that, Mwalimu, I've gotten 15 million Kenya shillings and that now I'm going to buy just one big bus. You will die with that big bus. You'd rather spread. Some of this amount goes to shares, like 5 million. Another amount in this case here goes to where? To, for example, government bonds. Some amount then can go to your motor vehicle business. Now, for us, for purposes of exams, ladies and gentlemen, this is what we are required here to know. Very few things here, really. Very few things here. So, for example, if you are given here states of the economy, you are given states of the economy, which could either be at A, B, C. ABC, state of the economy, ABC. And then we have the probabilities of these states. So probabilities here, we have 0.3, we have 0.2, and then we have 0.5, like that. Probabilities are given. And then, ladies and gentlemen, these people have given us returns of X. If we go for X, we shall get 15, 12, or 18, like that. R will be standing for returns. And then we have here returns of who? We have returns of Y in form of percentage. So this could be, for example, 9. We have, for example, 6. And for example, what year? Maybe 8, like that. So we have got two securities here. This could be shares of Safaricom, which will yield these returns depending on what you're depending on the state of nature. This could be shares of KCB. So returns of KCB shares in form of percentages, like that. Now, ladies and gentlemen, you know, they would want you to create a portfolio where you combine X and Y. This is how they will start testing you in this scenario. Number one, they'll tell you to calculate, expected returns. You calculate expected returns of X and Y. Calculate expected returns of X and Y. Let's first of all get a solution here. Expected returns of X. So how do we get expected returns of X? This E stands for expected. Now, because I'm seeing probabilities, can somebody talk to me? Because I'm seeing probabilities here, what should I do? Somebody talk to me. Tata, you multiply, yes. You will multiply, yes. You will take, in this case here, the actual returns of X times the corresponding probabilities. You'll take tata like that. Expected returns of X. So then we have, these are the actual returns that you shall multiply, in this case here, with what here? With probabilities. So expected returns of X will be equal to, we have here 15 times 0.3. That's the concept of tata. So 15 times 0.3 plus, we have here the second return, which is 12 times 0.2. 12, or we get this 18, or means we keep on adding. You know, there are three possibilities. It is either we get 15 with this risk, plus this 12 with this risk, plus this 18 times 0.5. So are you able to give me that figure? Are you able to give me this figure, expected returns of X? What do we have here? Expected returns of X. Patapotea, Merlin, 15.9. Is this 15.9, 15.9, 15. Are we able to get 15.9, all of us? 15.9, all of us. Thank you very much, Julie. So please go ahead and give me expected returns of Y. Go ahead and give me expected returns of Y. How do we get expected returns of Y? I can see the actual returns, there are three. But we do not know between the three which one is going to prevail. What I can see are probabilities here. So then I will take the actual returns of Y. I will take the actual returns of Y times corresponding what here? Probabilities. And then we sum like that. We sum like that. We sum like that. So ladies and gentlemen, this is what I will have. So the expected returns of Y, I can see the actual ones. So 9, remember the probabilities are normally the same. So 9 times 0.3 plus 6, 6 times 0.2 plus 8 times 0.5. So is there somebody who could be having this figure? So according to 7.9, Pure just confirmed 7.9. So don't put these percentages, just leave it like that. Don't put those percentages, just leave it like that. So ladies and gentlemen, up to here, are we comfortable? Have we known how to get expected returns? Have we known how to get expected returns? Thank you so much. Then the next thing will be for us to come here and give our examiner number 2 the measures of spread, what we call the standard deviation. Standard deviation. Standard deviation. Standard deviation, we shall always write standard deviation by writing 0 and then we pull like that. That is a standard deviation. Standard deviation. So in this case here, standard deviation of what here? X. So they want us to calculate the standard deviation of our securities. So ladies and gentlemen, standard deviation, this is a measure of spread. It's a difference. Difference between what and what? Difference between the actual returns and the expected returns. Difference. Deviation means you're subtracting. So actual returns and expected returns, which is what here? Which is average. Average here. Which question are we doing? It is this question. This is illustration. The question is here. We haven't done a lot. This is the question. But now remember, this is a special deviation. It must be squared, if you can remember from high school. And then we have measures of risk now. So the probabilities are measures. We must attach the probabilities. And because there are many, we must come and sum them. And then, of course, whatever you've gotten here will be called the variance. Then at the end of the day, we shall have to come here and do what here? Put a square root. We shall have to come here and put what here? Put a square root like that. And that is why standard deviation is called the root mean square. Root mean square. We normally call standard deviation RMS, root mean square. That once we have known in this case that this is the deviation, first of all, we square root mean square. We start with squaring. Then for the averaging, we shall multiply with P. And then, of course, at the end of the day, there is a square root. There's a square root, but it comes after you have summed here. It comes after you have summed here. If I were you, I would simply look at the deviation itself, which has to be squared, times probability. Every or each one of them, of course, put lumped together, so summed like that. And then at the end of the day, there is what here? A square root like that. So let's take this opportunity and calculate the standard deviation of what here? Standard deviation of X. So then this will be Rx, these ones here. There are 3 of them. I have 15, 12, 18. Minus, minus, minus. Are you able to remember our expected return of X? Are you able to remember our expected return of X? Expected return of X? Wait, they are forgotten. They are forgotten. Expected return of X, they are forgotten. It is here. It is here, 15.9. And what do you know about expected return of X? Expected return of X will not fluctuate. It will remain the same regardless of the economic situation. So this 15.9 will remain the same. This 15.9 will remain the same. Then come here, and in this case here, do what here? You square. Come there, and then you do what here? You square, like that. You square, you square, you square, you square, you square, you square. I'm following this. Get the deviations, get the subtractions here. Whatever subtractions you get, squared, each one of them, times their corresponding what here probabilities they are here. So times 0.3, times 0.2, times 0.5. So is there somebody who is able to give me these numbers? Anybody who is able to give me these answers? So how do we do this? I will come and say, open brackets, 15 minus 15.9, you close, you square, times 0.3. All right, so NIDA is giving me a figure of 0.243. I don't know whether it is all of us really who are getting this. I don't know. Please, here now we are revising. And I can't, given the experience I have with this examination body, I can't be very far away. I may not get it right 100%, but I can't be very far away from how your exams are set. So like now, this one, the only thing you are required to know is how to use your calculator. Everybody must use a calculator. So the second one, is there somebody who is able to give me the second one? You open brackets 12 minus 15.9, close. And then you say raised to power 2 times 0.2. So I'm being given 3042. I'm being given here 3042 with a decimal here. 3042 with a decimal there. And then we got the last one. What do we have there? The very last one, 2205. 2205 with a decimal here. And then come and, in this case here, give us the total. Come and give us the total here. Please add for us. I can see Win is saying, I can see in this case here, Esther Mutinda, 5.49, like that. Remember, whatever you've gotten here is called the variance. Because first of all, after you get these deviations, you have squared or multiplied them with probabilities, you need to come and sum. I've always seen and I've never understood why this certain follows my students. You get in this case here, certain, that must be Saturn himself, where students come and put square root in each one of them. And yet, the square root is supposed to be coming after summation. And therefore, the standard deviation of x will be 5.49 square root like that, which I'm being given here by Hilda, 2.34, 2 decimal places. Thank you very much, 2.34. Now, would you kindly do me a favor? Kindly write the formula of standard deviation of y. Write the formula of standard deviation of y. Tunaandika namna gani standard deviation? Write that formula. Standard deviation of y equals who? Standard deviation of y. Jaribu kuandika tu. Standard deviation of y equals who? Standard deviation of y equals who? Standard deviation of y equals who? Hebu andika tu tuone. Great. I can see what Winnie has there. Great. So in this case here, standard deviation of y. I will have y metrics. I will have y returns. Two of them, the actual vis-a-vis the average. Expected is the same as average. So then I'll come and talk about returns of y minus expected returns of y. This deviation has to be squared times probability. And because there are many deviations, then I must come here, in this case here, and sum. And then at the end of the day, we need to come and put here what we call a square root. So then the returns of y, we have been given the actual returns of where they are here. We have here 9, 6, 8, minus. Expected returns of y, the average, does not fluctuate. Once you give me the average, like here, I know expected return of y is 7.9, then I'll be able to use now 7.9 throughout. 7.9 throughout. And then I should be able to come here and square these things, square these deviations. So times the probabilities. Probabilities will always remain the same. So probability, we have here 0.3, we have here 0.2, we have here 0.5. So then are you able to give me these values again? If possible, actually 2 decimal places will suffice for me, will be sufficient. So we have 0.36. We have 0.36. Please go to the second one. Go to the second one. How are we doing this? No square root. It is 6 bracket 6 minus 7.9. You square the difference after closing brackets there. So Sherry, she's giving me 0.72. 0.72. I just want 2 decimal places. Eric, thank you very much. I want 2 decimal places. 2 decimal places. So the last one, of course, in your exam, you can do even 3 or even 4, because the more the decimal places, the better. But for my case, for somebody who is rushing like myself, ladies and gentlemen, then these has to be really something very, very what here? Something very, very small. The fewer, the better for me. The fewer, the better for me. So the last one, what do we have here? The last one. The last one, these guys are not giving me the answer. The last deviation. Can somebody give me 𝗖𝗙𝗙𝗙𝗘? Give me this figure here. Or is 0.72 the last one? I don't know. 0.005. Oh, now Mwalimu, that you say 2 decimal places, you can talk of 0.01 or 0.05. It doesn't matter really. It doesn't matter. If it's 5, it will be 0.0. That's okay. So please come and give me the total here. Please give me the total here. Please give me the total here. The total is 1 point. The total is 1.09. If you're getting 1.1, no problem. 1.00, no problem. For my case, it will be 1.09. Whatever you're getting there, really. Once we take a square root, it will kill that difference. Then go ahead and give me the standard. Therefore, the standard deviation of y will be equal to the square root of 1.09. The standard deviation of y will be equal to the square root of 1.09, which will give me approximately 1.044. 1.0, regardless of what you took here. At the end of the day, you'll get like 1.044, 1.041, 1.04, one and the same. One and the same. So now, my great friends here, my students here, have we understood how the standard deviation, it's a measure of disparity. Have we understood how this standard deviation is calculated? Are we comfortable? All right. Now, after that, ladies and gentlemen, I know how these examiners try to confuse my students. After that, they would want to know whether you know how to associate the securities as a measure of association. How are the securities related here? So they would want you to calculate what we call covariance. What we call covariance. I would want you to calculate covariance. So number 3, the third one is called covariance. The third one is called covariance. Covariance. Now, especially for somebody who is at the mid-age, 45, 46, around there, whenever you hear of this word co, because of this midlife crisis, we really have to be very, very scared. Because co means common. So this is common variance. Common variance, which is the same as what here? Shared variance, which is the same as shared variance, which is the same as shared variance. You know, anytime you hear of, like, for example, if somebody says, if you're passing somewhere, as a lady who came to amesema, we're going to call wife. As mtu asema we're going to call wife. I mean, that will not be interesting. That won't be interesting. That means that there is somebody somewhere who is being shared, isn't it? Who is being shared. So the same case here with this covariance. It is the shared variance. Sorry for using a bad example. I'm so sure some of you will not want to be hearing such kind of things because of your salivation. We shall overcome. We shall overcome. We shall overcome. So covariance. How do we get this covariance between, say, x and y? It's very easy. You will take the deviation of x. You multiply this with the deviation of y times probability. And then at the end of the day, you do what here? You sum. So you take the deviation of x, because you know you hapa bibi ni wawili. Bibi ni wawili. Kuna bibi wa kwanza na mashida zake. Kuna bibi wa pili na mashida zake. And then of course you average them up by multiplying with what here? Probability. All right. So then how do we get deviation x? So to get deviation x, as we said initially, this is about subtracting. So we have here returns of x minus expected returns of x into deviation y is returns of y minus ERY. Whatever we get here, we shall come and multiply this with what here? With probability. Whatever we get, we shall multiply with probability. And then, of course, at the end of the day here, there is a summation. There's a summation. In covariance, hakuna kupata square root. In covariance, hakuna kuweka square root. Hiyo inakuanga namna hiyo, covariance. So then our work will be to populate this. Our work will be to look for figures to put here, which is a very easy thing. So like, for example, the returns X, we have returns X there, 15, 12, 18, minus, minus, minus. Expected returns of X, you guys did give me a figure. It was 15.9, 15.9, 15.9, like that. Times actual returns of Y, times actual returns of Y, times actual returns of Y, minus expected returns of Y. The actual returns of Y are given here. I'm simply copying them down. Those ones normally will dance in accordance to how the economy will behave. So in this case here, the actual returns of Y, we have 9, 6, and 8. Minus, 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 we happen to be having expected return of Y, which is 7.9, 7.9, 7.9. Expected does not change. Expected does not change. Expected does not change. Expected does not change. Times probabilities, these ones here. So we have 0.3, we have 0.2, and then we have what here? 0.5. Then we have 0.5. Then we have 0.5 here, 0.5 like that. So then is there somebody who can give me these answers two decimal places? But I've seen there is a risk there. Let's put them as 3. Let's put them as 3 decimal places. 3 decimal places. 3 decimal places. Let's make them 3. Let's make them 3. Let's make them 3 decimal places. Abracadabra, what are we doing here? We are opening brackets. 15 minus 15.9, you close. You say times, open another bracket. 9 minus 7.9, you close, times 0.3. So according to 𝗖𝗙𝗙𝗘, it is 0.29, negative 0.297. Negative 0.297. Negative 0.297. Negative 0.297. And then you go to the second one. Second one, we have 1482. 1482. So here we have 1482 with a decimal there. And then the last one will be opening brackets here, 18 minus 15.9. You close. You say another times. You must say times in between there. You open another one, 8 minus 7.9. You close, times 0.5. What are we getting there? What are we getting there? So 0.105. So we have here 0.105. Then, of course, at the end of the day, they want us to sum. 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 At the end of the day, they want us to sum. They want us to sum. So whatever summation we'll get, there is nothing like getting a square root. Whatever summation we'll get will be the covariance. Will be the covariance. So covariance, ladies and gentlemen, here is 1 point what here? Is 1.29. Covariance is 1.29 from Maggie. Covariance is 1.29. So if, for example, this class was to end here and now, and then somebody asks you in this case here, what have you learned about covariance? What is your take out of this particular classroom regarding covariance? What is it that you'll never forget about this covariance thing? Yeah, the co-wife that you will take in this case the deviation of the first wife, who is X, times the deviation of the second wife, who is who? Y, times their probabilities. Times their probabilities. Has no square root. No square root. Covariance has never had a square root. Thank you very much. Thanks, Paul. Great, great. So this is a very, and you must remember this formula really, that covariance of X and Y, you take the deviation of X times the deviation of Y times now probability, and then you do what here? You sum, and then you sum like that, and then you sum like that. Now, ladies and gentlemen, from there, number 4 with your permission, these guys here will come and ask you to give them the correlation coefficient. So we have number 3, correlation coefficient, which is what here? Our R. So correlation coefficient, which is our R. So how do we get R between X and Y? So this is basically the standardized covariance. So this is the standardized what here? The standardized covariance. The standardized covariance. In short, ladies and gentlemen, whenever they want me to give them the correlation coefficient R, I will take the covariance between XY. I will take the covariance between X and Y divided by what here, somebody? The respective standard deviations. You divide by the respective standard deviations. So anytime they want me to give them the correlation coefficient, this one here will be equal to covariance between X and Y divided by the standard deviation of X divided by standard deviation of what here? Y. So I would want then you guys to do me a favor, go ahead and calculate this correlation coefficient pretty fast. Please go ahead and calculate the correlation coefficient pretty fast. Remember, already we have the covariance. Are you able to remember the covariance? Hey, you, my great people. Was it 1.29? Was it 1.29? Was it 1.29? The covariance that we have computed there. Yes. All over the standard deviations that I rubbed mine. I did rub mine. The standard deviation of X was what? The standard deviation of X. The standard deviation of X, 0.53. How about standard deviation of Y? The standard deviation of Y. Standard deviation of Y, what do we have there? 1.044. 1.044. So please remember that you must always put this in brackets like that when you're dividing. When you're dividing. When you're dividing. So for X, what do we have here? Let's get this. For X, what do we have here? For X, what is the standard deviation of X? 0.23 times 1.04, I don't know. Let me repeat this. So please remind me, what is the standard deviation of X? What is the standard deviation of X? Standard deviation of X, 2.34. How about the standard deviation of Y? Standard deviation of Y, 1.041. So then put this in the brackets. Take this 1.29 divided by open brackets because these two deviations are together down there, denominator. So we must, in this case here, put them in we must put them in brackets. So then the final answer I'm being given here is 0.53. 0.53. I'm being given 0.53. I'm being given 0.53. R, the correlation coefficient is 0.53, meaning that the two securities are related to the tune of 53%. I don't want to teach you how to interpret. For now, I just want us to master the formulas. For now, I just want us to master the formulas. So that is correlation coefficient. That's correlation coefficient. That's correlation coefficient. All right. So I believe you guys are taking some few minutes in between here to memorize these formulas as we get along. Let's not postpone thinking and say that right now we are only copying and then later on we shall be able to do what we shall be able to cram. No. It's now or never. Everything is real time. Everything is real time. Everything is real time. Real time. Ladies and gentlemen, we go to number, is it number 4 or number 5? I think it's number 4. So number 4, these guys will ask you to ascertain the coefficient of variation of X and coefficient of variation of Y. I'm putting them separately like that because those ones you can only compute them for each. You can only compute them for each security or for a portfolio. So basically, I will start by giving what we call the CV of X. How do we get this CV of X? Anytime they talk about CV in finance, CV is sex in percentage. Sex in percentage. Anytime they talk about CV, that's how I remember CV. I'll never forget this. So to get CV of X, ladies and gentlemen, we shall take standard deviation over X bar times 100. Remember my sex here is ladies and what here? Gentlemen. It's gender. It is gender, Frida. You. I'm talking about gender. I'm talking about gender. Nobody has some corrupted mind here. All of us are doing very well. So in this case here, we are looking at what here? At gender. So S over what here? X bar. S over X bar times 100. S over X bar times 100. So in terms of then our symbols here, CV will be standard deviation is written like this. All over X bar, this will be expected returns of X because X bar is the mean. 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 So then is there somebody who can give me this figure of CV? Somebody who can give me this figure of CV, as of course, some of you are cursing me for having used a bad name. Don't curse Mwalimu. I simply want you to remember these things many years, even after today. So do we remember the standard deviation of X? Is there somebody who is able to remember the standard deviation of X? Somebody remind me, the standard deviation of X equals who? The standard deviation of X equals who? Equals 2.34. Equals 2.34 all over expected return of X, which is 15.0 15.9 times 100, which in this case here, somebody has been able to give me the figure. Somebody has been able to give me the figure. When I'm there, the final figure is 14.7%. Matthias has confirmed that. Matthias confirmed that. Then in this case here now in your wisdom, are you able to give me the CV of Y? Are you able to give me the CV of Y? Now in your wisdom, Winnie tells me it is 13.22. It is 13.what here? It is 13.22. Is that correct? 13.22, is that correct? Is that correct? How I wish I would get really these figures from everybody. Celine, Daisy. Today I'm not hearing you guys. 13.what here? 22. 13.22. 13.22. 13.22. 13.22. Like that, 13.22%. So remember that CV is a measure of risk. The higher the CV, the higher the risk. The higher the CV, the higher the risk. So in that case here, then which one is more riskier than the other? 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 X, right? X. X. CV nilikuwa nimesahau. Sasa Paul, kusema ukweli, kutoka leo utaweza sahau CV kweli? Hata mtu akienda kwa interview akuulize swali ya kumesha risk, akuulize formula ya CV, unaweza kusahau kweli Paul? Unaweza kusahau tena kweli? No, haiwezekani. Hiyo sasa hiyo imekuwa part and parcel of us now. Hata yule ameconfirm imekuwa part and parcel of us now, moving forward. Now, ladies and gentlemen, please, I would want you guys to do me a favor. I would want in this case here somebody to write for me. They are closing their eyes like they are. I'm closing mine. Expected returns of X equals Rx times P. Of course, there is a summation. Then, ladies and gentlemen, I would want somebody in this case here to go ahead and remind ourselves the formula of standard deviation of X. Jifanya kuwa unafunga macho kama mimi kidogo. Jaribu kuona kama imeingia kwa akili. How do we get standard deviation of X? How do we get standard deviation of X? How do we get standard deviation of X? Standard deviation of X. Standard deviation of X. So standard deviation of X, I can see it vividly. Deviation means subtraction. So I'm having here Rx minus ERX. And then this has to be squared times probability. And then we sum like that. And then at the end of the day, there must be what here? There must be a square root. The other one that I would always want my students here to remember throughout without forgetting it at all is the covariance. Unfortunately, you will get so many guys telling you that covariance is sex in percentage. No. Covariance is the one over co-wife. Is the one of two people involved here. So covariance is the one where we take deviation of X times deviation of Y times probability. And then we do what here? We sum. All right. I can see what Winnie has written there for me. So deviation of X, in this case, it is Rx minus ERX. Division of Y is RY minus ERY times probability. Like that. I just wanted you to have a recap of those three. Then how do we have these tested? How do we have this tested in our exams? How do we have this tested in our exams? How do we have this tested in our exams? Unfortunately, let me tell you, see right now you are there saying, Mwalimu, I can never forget this. Mwalimu, I can never forget this. In our tomorrow's class, you'll be surprised to get that so many of us in this case here will have forgotten all those formulas. Do you want us to bet? Do you want us to bet as regarding that? Do you want us to bet on that line that when some of you come here tomorrow, you'll have forgotten the entire formula set, the entire formula set, the entire formula set? Do you want us to bet on that? Inakaaje sasa? Hebu tuangalie September 2021. September 2021. September 2021. Question number 1, boy. Softex Limited. Question number 1, boy. User. I wish I knew your name, user, because I'll ask you this formula tomorrow. You will not be remembering any formula. We can bet. 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 So then we have here September 2021, question number 1, boy. Softex Limited. Are we there? September 2021, question number 1, boy. Softex Limited is contemplating building a 3-asset portfolio comprising assets of firms A, B, and C. The company wishes to invest 5 million in the shares of these firms. Given below are the number of shares and the current market prices per share. So we have A, B, C. We have number of shares, and then we have market prices per share. Now, ladies and gentlemen, when you see that kind of information, even if you are not told, I cannot fail in AFM, I will always pass. Because when I see here, these guys are giving me like the nose, number of ordinary shares, and then they're giving me MPS. Then they're giving me MPS. So like A, I can see A 50,000. I can omit the thousands. So this is 50. This is 32.5. And this is 40. And then, ladies and gentlemen, MPS, I can see MPS there is 50, 40, 30. 50, 40, 30. When you see these two sets of information, tell me, what do you think will be the best thing for you to do? What will you do? Don't tell me that you have not learned the topic. No. There are things which are general knowledge. Things which are general knowledge. Multiply to get the total value. Because you see, these are 50 shares and each share is worth 50. So get the total value. Total value. So total value will be NOS times MPS. So are you able to give me those values very fast? Multiply to get the total value, yes. Multiply to get the total value. Abracadabra. Abracadabra, oh yeah. So this will be 50 times 50, which is 2,500. This will be the 2.5 times 40, which gives me what somebody there, please, 𝗖𝗙𝗙𝗙𝗘, thank you very much, 1,300. 1,300. Then we have 40 times 30, 40 times 30, 40 times 30, inakuja ngapi somebody Magi? Ameniandikia pale 1,200, Magi leo ako na mbio kule kweli. Very good. So what is the total? What is the total? What is the total? What is the total, abracadabra? What is the total, abracadabra? Leonida Matunda, thank you very much. So Magi again has given me 5,000. Now let me ask you a simple question, you children of God. What do you think shall I use this total value column for? What do you think shall I use this total value column for? Thank you, Esther, 5,000. Expected returns? No. We shall use this to get the weights, yes. We shall use this to get the weights. So I shall be able to get now the weights here. So the weights were here, the decimals, the proportions. So like how much will it be invested in A? It will be 2,500 divided by 5,000, divided by 5,000, divided by 5,000, abracadabra, abracadabra, abracadabra. Please give me these figures pretty fast. So according to Esther Mutinda, ameniambia ya kwanza ni 0.5. Ameniambia ya kwanza ni 0.5. Ya pili je? Ya pili je? Julie uongo akijuli mendanganya. Ya pili ni 0.26. Hii iwezi kuwa 0.52 Julie. Hiyo ni 0.50. Hiyo mimi naona na macho kabisa. Aha, ya mwisho itakuwa 0.24 if I'm not wrong. 0.24 ndio ziweza ku add up to 1. Ziweza ku add up to 1. So hii ni max inatembea tu. Hii ni max inatembea ovyo ovyo. Hii nimepata correct. Hii ni mark inatembea tu ovyo ovyo. Ladies and gentlemen, after that, then I'll be able to go ahead and read the question. I'll be able to go ahead and read the question. Abracadabra. They are telling me the forecasted market price for each share after 1 year and their probabilities of occurrence in different states of nature are as given as follows. They've given me probability there. They have given me, ladies and gentlemen, additional information. They've given me additional information. The correlation coefficient of the returns of the assets are given below. So they've given me correlation coefficients. Good examiner. So Roman 1, they want me to give them expected portfolio return. They want me to give them expected portfolio return. Expected portfolio return. Unaweza ama uwezi? Unaweza ama uwezi? Yeah. Unachokora max, yes. Unaweza ikweli ama uwezi? Hii kitu haikuwa rahisi hivyo. Hii semester wanafunzi walilamba chini na hiyo swali sana. Because wanafunzi walisahau what we taught them, basics ambao tuliwafunza hapa. Basics ambao Paul anasema easy. Now, unajua hapa kupata expected return shida iko wapi? Ule jamaa alikuja pale akakupatia share price at the end of the year. You can see those things that some of you will confuse. Those things are in shillings, and yet our returns are supposed to be in a form of percentage. In form of percentage. Sylvester, ukinunua mkate leo, ununue mkate leo shilingi 100. Hii ni today. And then you become very lucky. Tomorrow, you sell this, in this case here, for 150. I want you to give me the percentage profit. And by Bwana Sylvester, hii bread, amenunua na 100, tomorrow akauza na 150. What will be the, because we must know how to convert our returns to percentages. We can't work with returns being in Kenya shillings. Uongo Winnie sasa formula gani umenipatia Winnie? Uongo. Mimi nimekuuliza hii swali hii. Profit yake itakuwa ngapi? All right. So in this case here, there are two ways. You could come and take the profit, which is 150 minus 100. You divide by the original. Which is what here? Which is 100. You divide by the original, which is 100. You divide by the original there, which is 100. Which then will end up giving us 50%. 50%. Sini kweli? 50%. But you see, again, in this case, you'll get some student telling you, Mwalimu, we can get this thing in a very easy way. Which easy way is this, Mwalimu, you're talking about? That you can take the new value, which is 150, you divide by the old value, which is 100, minus 1. Oh, umenipoteza. Okay, no problem. Sorry. Umepotea wapi? Oye, umepotea wapi accountant? Oye, umepotea wapi? Profit huwezi potea. Yani hii kitu mkate umenunua 100 bob. Ukauza kesho 150. What is the profit earned there? Sini 50 bob in terms of shillings. Sini 50 in terms of shillings. Huwezi ukapotea. Trust you me. Maybe network ilipotea. So ume earn 50 out of what? 50 out of what? Remember, it's the return on your investment, isn't it? So you had invested 100. So you take, in this case here, 150 minus 100. Whatever you get there, you divide by the original price, which is 100. And if you do it that way, then you shall be able to get 50%. I believe you unajua hata kwa kazi hiyo. Unajua ni network ilipotea. Lakini sasa uko sawa. Uko sawa kweli, nijibu hapo sasa. Uko sawa kweli ama bado? Sasa iko sawa. Unajua network inaweza potea njia mingi. Unajua sasa hivi mna sacrifice a lot. You guys are sacrificing a lot. All right. Mwingine angekuambia, Mwalimu, take the new figure, which is 150, you divide this by the old figure, which is 100, and then whatever you get, you subtract 1. And then the answer, of course, you shall convert it to percentage. Will we get the same answer? New value over the old value minus 1. Will we get the same answer? Will we get the same answer? Yes. Kidogo, kuna swali hapa kidogo. It's for which year? Langat Amos, this is September 2021, question number 1B. September 2021, question number 1B. Aya, sasa nisikizeni. Sasa nisikizeni abrakadabra. Kujeni hapa sasa. Oye. Unaandika namna hii oye. Unasema economy. Economy. Economy tuko na boom. Boom. Tuko na normal economy. Na tuko na recession economy. Recession economy. Recession economy. Na hapo wametupatia probability. Wametupatia 0.3. Tuko na 0.4. Tuko na 0.3. Kujeni hapa sasa mnipatie returns of A in percentage. Sio returns of A in prices. Kama hapa sasa, if it is the booming economy, I can see the price ya A itakuwa 60. So I will take 60 divided by the original. Is there somebody who is able to remember the original price? Oh yeah, the original price ya A ilikuwa ngapi? Langat karibu. Original price ya A ilikuwa ngapi? Oh yeah. Original ni sawa na current. Oh yeah. Niko peke yangu. Au tuko na Winnie. Pia tuko na Paul. Tuko na huyu online student. Tuko na Hilda Onderi. Great. So in this case, the original ile tulikuwa na hapa current. Ile iko hapo juu kwa table ya kwanza. So hapo utasema 60 over 50 minus 1. If the economy will be normal, I will use 40. 40 is the new price. All over the current price, which is 50 minus 1. If, for example, the economy will be receding, the price I can see there is 48. The price I can see there is 48. 48. All over the original will be the same throughout. Minus 1. Whatever figures you get, you multiply by 100. You multiply by 100, and then you tell me, in this case here, what are we getting? In form of percentage. In form of percentage. I would want us to leave those percentage because percentage is represented up here. Hapo nimeenda mbio kidogo. Mwanafunzi akisema nimempoteza, nitakubali. Hapo nimeenda mbio kidogo. Mwanafunzi akisema nimempoteza, hapo nitakubali. Roho safi, nitakubali. Nitakubali hapo. Unasema true, hapo nakubali hapo. Lakini si ile ya mkate, nimekataa. Ile ya mkate nimekataa. Okay, thank you very much. As I answer purity, I'm told you that the second one is 55, and then the last one will be what here, somebody? As I answer purity. As I answer purity, that's a very good question, purity, because most students, normal should be 55, normal. What is it? 55, normal. Is this 40 or 55? Oh yeah. Oh, it's 50. Then sasa mimi nimetoa 40 wapi? Hata mimi nimetoa 40 wapi? Kwa hivyo inafaa kuwa 55 over 50 minus 1. So ile is giving me a figure of 37.5. 37.5. Ya mwisho ninaweza kujibu wanafunzi haraka haraka, ya mwisho inakuwa negative ngapi? Ya mwisho inakuwa ngapi? Abracadabra. Ya mwisho will be a negative this divided by this minus 1. Ndio nijibu wanafunzi wote, tukue wote pamoja. Nataka tukue wote pamoja. Paul is saying that the answer is 0. 48 divided by 50. Whatever answer you get. Ngoja kidogo. I think kuna error mahali. Because kuna 60, 55, and then we have 48. Actual return. I'm being told in this case here, 20. Omeleta makasiriko. Oh, mnasema percentage. So I may understand. Then that's okay. So percentage is 10. That's okay. Percentage is 10. 10%. How about the last one? Sio 48 over 30 wini mendanganya hapo. Sio 48 over 30. Inakuja 4% negative lakini, isn't it? Negative like that. Please listen. Another student atakwambia mwalimu hapa kwa return returns of A, to get returns of A in form of percentage, utakwambia mwalimu chukua new minus old over old, ama original, ama current, times 100. So, unajua tunajiuliza what if analysis. What if analysis. Remember the current price ya A. Wewe unauliza tumetoa price ya A ni wapi? Price ya A, the current one is in the first table. Is in the first table. Are you able to see that? First table. First table. The first table. The first table. So remember, when we touch on A, we shall use for A, we shall use 𝗖𝗙𝗙𝗙𝗘 50, 50, 50, 50. When we go to returns of B, we shall be using one price, 40, 40, 40, 40 𝗖𝗙𝗙. When we go to product C, we shall be using one price, 30, 30, 30, 30 𝗖𝗙𝗙. Are we together there? Now we are handling A alone. It is only the economic situations that are changing. It's only the economic situations that are changing. So in this case here, come here, return of A, if you want to use this old formula. So the current return of A, ladies and gentlemen, I'm able to see from this table is 50. That's the current return of A, which I'll use now throughout here because I'm talking about product A. So then the new value, if the economy will be booming, I can see down there the forecasted price. If the economy will be booming, then I will have a new price of 60 minus the old of 50. Old is this one here. Divide by old again, which is 50. Whatever I get times 100. Can somebody confirm that we shall get 20%? Can somebody in this case here confirm that we shall get 20% there? Remember, that is still security A. But now the economy booming. What if the economy will be normal? If the economy will be normal, the price here will be 55. Minus the very old price here, A haita fluctuate. The old price here, A itabaki 50. Divided by the old, which is 50. Can somebody confirm that we shall get 10? Please take your calculator. Everybody should use their calculator. Everybody should use their calculators. I can only see it's only Leonidas who is saying yes. Now we are correct. Now we are correct, and all of us are in agreement, because I saw this one here confusing students even in CASNEB exams a lot. A lot. What we are hearing, we're telling us that mwalimu use C. No. Now we are through with the A. Then can somebody then do the same computations now for me for B? Abracadabra, as we see, as we go, we have only 1 minute. We only have 1 minute. So for B, so returns of B, what do we have here? Returns of B, abracadabra. Wacha tuone in form of percentage. So I'm raising my voice because I know these are sensitive area. Wacha tuone Nancy. Yeah, amesema yake 25. Ya kwanza kabisa, I think I should give a present here. Nancy amesema ya kwanza nafaa ikuwe 25. Ni ukweli kweli. 25, 15 and 87.5. Hebu tuone ya B. Ya B naona pale kuna 50. So nitasema 50, 46. Kwanza naandika namna hiyo. 50, 46. Alafu kuna 35. Hiyo ni ya B. Alafu nakuja nasema divide by the original price ya B iko ngapi? Original price ya B iko ngapi? Somebody, original price ya B kama unafuata. Original price ya B ni ngapi? Kama unafuata ni 40. So tutasema over 40, 40, 40. Sita change the base. Minus 1, minus 1, minus 1. Whatever I get, then I should be able to do what here? I should be able to multiply with 100. And then, ladies and gentlemen, for me to be able to answer now after this, you guys should be able to, yeah, it's exactly 2. The question, the session had started becoming very nice. But because of respect for time, thank you very much. See you tomorrow at the same time. And we are making progress. We shall overcome. Bye. Say hi to your bosses. Say hi to your bosses. Today you are saying hi. Oh, I do LM as well. We shall overcome.